In the quiet stillness of night, when the ticking of a clock becomes louder than thought, we feel at that invisible river, always moving, always pulling. Time. We mark it in moments. A heartbeat, a breath, the fading warmth of a memory. We measure it with tools, sunrise to sunset, calendars to atomic oscillations, and yet no one has ever touched time. No one has seen it. No one has heard its true voice, only its echo. In everything that changes, from the swirl of galaxies to the flicker of a candle, from the aging of a star to the wrinkle on a FaceTime, seems to be the stage on which all things unfold. A line drawn from past to present to future, a promise of motion, of story, of cause and effect. But what if it isn't? What if time is not a river, but an illusion? What if past, present, and future are not flowing but fixed? What if everything we remember, everything we anticipate, already is etched into the fabric of reality like the grooves of a vinyl record? For millennia, we've lived inside this mystery. Ancient civilizations spoke of time as a cycle, the wheel of life turning through birth, death, and rebirth. Others believed time was a divine rhythm written into the heavens by gods. Then came science with its clocks and equations, and the illusion hardened. Time became a line, unidirectional, absolute, until it wasn't. Einstein bent it. Quantum physics questioned it. And today, some of our most brilliant minds are beginning to ask, does time even exist at all? This documentary is not here to give you certainty. It's here to invite you into doubt, to explore what happens when we peel back the curtain and ask not what time it is, but what time truly is. Is it a dimension, a construct, a shadow cast by change, or the very breath of the cosmos itself? We will journey through relativity and quantum weirdness, philosophy and myth, science and soul. And we will try quietly, reverently, to glimpse what lies beneath the ticking hands of the universe. Because if time is an illusion, then perhaps so is our beginning. And maybe, just maybe, there is no end. Before there were clocks, before the hands of time ticked across dials and digital displays, there was only the sky. The sun rose, the sun set. Seasons shifted, leaves turned gold, rivers froze and thawed. The ancients did not count time in hours or seconds. They felt it, an endless rhythm, the pulse of a living world. In India, in Greece, in the highlands of the Andes, early philosophers and priests spoke not of time as a line, but as a circle. Birth led to death, and death gave birth again. Civilizations believed in cosmic cycles, yugas, kalpas, eons. To them, time was a wheel, not a road, and in some deep intuitive way, they were right. Look closely at nature, and you'll find repetition, recurrence, rhythm. The moon waxes and wanes. Tides rise and fall. Your very heartbeat dances to the beat of a biological drum. But then came the machine. The Industrial Revolution demanded precision. Train schedules, factory shifts, a ticking order imposed upon the chaos of life. Time was no longer a sacred rhythm. It became a ruler, a master. And from that moment on, we began to think of time differently, as an arrow, a line with a beginning, a middle, and end. The idea of time as linear wasn't entirely new. In the West, especially in Abrahamic traditions, history was viewed as a story with a divine plot, a genesis, a judgment, a destiny. Time moved forward, driven by divine will or historical purpose. But in physics, this linearity had to be proven, measured, described. To Newton, time was absolute, a cosmic metronome that ticked evenly, universally, without variation. It didn't matter if you were here or on the far side of Jupiter. Time was the same. Second was a second. A minute was a minute. A clock, properly tuned, could measure the very heartbeat of the cosmos. This was comforting, orderly, rational, and yet incomplete, because it didn't explain the arrow. Why does time move forward? Why do eggs break but never unbreak? Why can we remember the past but not the future? This one-way motion, the arrow of time, is something we experience intuitively, but struggle to define scientifically. The key physicists discovered lies not in time itself, but in entropy. Entropy is the measure of disorder in a system. A hot cup of tea cools down. It never spontaneously heats back up. A sandcastle crumbles and never reassembles itself. The universe, once young and ordered, is slowly spreading into cold and quiet chaos. This is the second law of thermodynamics. Entropy always increases. And so time seems to have a direction because entropy does, not because clocks demand it. Not because the universe prefers one moment over another, but because disorder spreads. This is time zero, etched not in the laws of motion, but in the mathematics of decay. And yet, nature has not forgotten the cycle. The cells in your body die and are replaced. Forests burn and regrow. Civilizations rise, fall, and leave seeds behind. Even stars die, only to scatter their elements into space. Birthing new stars, new planets, new chances. Cosmologists once believed the universe itself might follow such a pattern. A Big Bang, followed by expansion, slowing into collapse, ending in a big crunch, only to rebound into another bang. A cosmic heartbeat, a divine breath. Today, with dark energy pushing the universe outward faster and faster, the idea of a collapsing cosmos seems less likely. But the yearning for cycles lingers in our mythology, our poetry, and our physics. Perhaps it's because linear time feels alien to life itself. The truth is, we don't live in equations. We live in memories. We live in seasons. We live in rhythm. The arrow of time may be etched into entropy, but our experience of time remains stubbornly cyclical. We celebrate anniversaries. We mark birthdays. We grow older in repeating rituals. Time loops through us. Even as it marches forward, we dream in flashes of the past. We plan for futures we may never see. And always, we return to the now, this eternal, fleeting present. It is in the now that the cycle and the arrow collide. So, is time linear, or is it cyclical? The answer may be both. For physical systems, entropy gives time its direction. But for conscious beings, time loops, bends, folds. You revisit the same thoughts, you fall in love again, feel grief anew, learn old lessons as if for the first time. Our experience of time is richly non-linear, even if the physics suggests a one-way street. And what if, this arrow is not fundamental at all? What if it's only a byproduct, a side effect of how the universe began? Then everything, the past, the future, the now might be coexisting forever. The arrow would be an illusion, and the circle would return. We often say, time flies, but in truth, time doesn't fly. We do. We fly through it, drifting on its winds like autumn leaves, unaware whether it is the current that moves, or the illusion of motion upon a still sea. Ask a physicist and they'll tell you the laws that govern our universe. Newton's mechanics, Maxwell's equations, even Einstein's relativity are time-symmetric, meaning this: if you reversed time in the equations, they would still work. A ball flying through the air obeys the same laws, whether played forward or in reverse. A galaxy spinning would follow the same physics, regardless of direction. There is no preferred flow in the mathematics, and yet, the teacup falls, but never rises. The candle burns down, but never grows back. We are born, we age, we die. This disconnect between the symmetry of the equations and the asymmetry of our experiences, one of the most profound mysteries in all of physics. Where, then, does this asymmetry come from? The answer, as before, leads us to entropy and to the question few dare to ask. Why did the universe begin in such an incredibly low entropy state? At the very moment of the Big Bang, the cosmos was hot and dense, but remarkably smooth and ordered. If you could observe the energy of that primal instant, you wouldn't see chaos. No, you'd see balance. This is strange. For an explosion, we expect mess. We expect unpredictability. But the Big Bang was, paradoxically, a picture of simplicity. A clean slate. And from that low entropy state, everything has spiraled outward toward disorder, toward complexity, toward the thermodynamic heat death we now predict as the universe's final breath. Entropy increases, not because the laws demand it, but because it began so low. Why? We don't know. Perhaps it was divine symmetry. Perhaps it was a quantum fluctuation, a 1 in a trillion event from a prior vacuum. Or perhaps it wasn't a beginning at all, but a turning point in a larger cyclical story. If the universe is truly a loop, if time folds back on itself, then the Big Bang may not have been the start, but merely the hinge between what was and what will be again. Long before modern physics, ancient minds dreamed of recurrence. The Stoics of Greece believed in the ekpyrosis, a fiery end, followed by renewal. The Hindus wrote of kalpas, eons of creation and destruction, repeating in divine rhythm. The Mayans mapped time not in lines, but in wheels. Today, echoes of these ideas return in modern garb. The Big Bounce, conformal cyclic cosmology, loop quantum gravity. Each suggests a universe that may rebound, refresh, repeat. Perhaps the era we see is only a section of a larger cycle, local vector within a cosmic circle. Even entropy, that god of decay, may not reign forever. In some speculative models, the very definition of entropy changes as the universe expands. What seems irreversible in one epoch may become reversible in another. This doesn't mean time as we know it will loop in a human sense. You won't live your life again, frame by frame. But it may mean the arrow itself is not eternal. It may rise, curve, and return. Even in our daily lives, the cycle asserts itself quietly, insistently. We live by calendars that reset. We wake and sleep, plant and harvest. We mourn and then love again. There is something deeply human in the act of returning. We revisit places not to see them anew, to see ourselves again through the mirror of time. A parent reads their favorite childhood book to their own child. An old man visits the sea where he once proposed. A song from long ago drifts through a cafe, and the years collapse. Linear time measures motion, but cyclical time measures meaning. It is in the repetition that memory grows rich. It is in the return that we find the sacred. Perhaps this is why art, myth, and rituals so often speak in cycles. Because in those loops, we recognize something truer than measurement. We are more than where we are going. We are also where we've been. Time, for most of history, was seen as constant. As reliable as the rising sun, as immovable as the mountains. But in the early 20th century, a quiet mind in a Swiss patent office cracked that illusion wide open. His name was Albert Einstein. And what he revealed would unravel not just time's constancy, but the very structure of reality itself. Einstein's revelation came in two great waves. The first, in 1905, was special relativity. The second, in 1915, was general relativity. Together, they reshaped time. Not as a universal beat, but as something deeply personal, deeply relative. A phenomenon not separate from space, but inseparably bound to it. In Newton's cosmos, space and time were two different arenas. Space being the stage, time being the ticking of a cosmic clock. But Einstein showed that space and time are threads in the same fabric, a four-dimensional tapestry called spacetime. And that fabric can bend. Imagine the universe not as a fixed grid, but as a supple sheet. Place a massive object, say, a star in that sheet, and the fabric curves. Now roll a marble past that curve. The marble doesn't move in a straight line. It follows the bend. This is gravity, not a force, but the shape of space-time itself. And here's the key. Where space-time bends, time changes. To most of us, time feels like it flows at the same rate for everyone. A second here is a second there. But relativity says otherwise. Time is not absolute. It is elastic. It stretches and shrinks depending on motion and gravity. Move fast enough close to the speed of light and time slows down for you relative to someone at rest. Stand near a strong gravitational field, a black hole, a neutron star, and your time ticks more slowly than it does for someone farther away. This isn't science fiction. It's been measured, proven. Astronauts aboard the International Space Station, moving at 28,000 kilometers per hour, age slightly slower than those of us on Earth. GPS satellites orbiting our planet must account for both gravitational and velocity-based time dilation, or else their signals would drift by kilometers each day. But perhaps the most famous illustration of time's elasticity is the twin paradox. Imagine two identical twins. One stays on Earth, the other boards a spaceship and travels near the speed of light, then returns. When they reunite, they are no longer the same age. The traveling twin has aged less. Years may have passed for one. Mere months for the other. It's not a trick. It's not a malfunction. It's a feature of spacetime. In the realm of relativity, simultaneity, the idea that two events happen at the same time no longer holds. What is now for one observer may be then for another. Past, present, and future become slippery concepts, dependent not just on where you are, but how you are moving. This leads us to a profound, almost unsettling thought. Every observer has their own timeline, their own flow, their own present. Time, once thought to be the great equalizer, is instead the most personal of dimensions. Let's pause for a moment, because the implications here are staggering. If time flows differently in different places, at different speeds for different people, then what becomes of reality itself? What does it mean to say this is happening now, if now is not universal? Just picture this. On the surface of a black hole, time slows to a crawl. To a distant observer, it appears frozen. But to the astronaut falling inward, time marches on. Their heartbeat continues. Their mind still races. Two realities, one moment, both true. Now take this farther. What if the edge of a black hole, a place called the event horizon, is not a wall, but a boundary between radically different temporal experiences? A realm where past and future blur. Some physicists speculate that inside a black hole, time may even reverse, or stop altogether. If true, then somewhere in the vast cosmos, time itself may already have broken down. And yet we live as if it were linear, absolute, governed by calendars and clocks. But clocks don't measure time. They create it by providing a rhythm, a beat, a metronome. But that rhythm can change. That beat can slow or quicken, depending on where you stand, how fast you move, and how much mass surrounds you. What's remarkable isn't just that time bends, but that our minds can grasp this. That we, temporary creatures living on a spinning rock, can build machines, run experiments, and confirm these strange truths. In 1971, physicists put atomic clocks aboard airplanes. One flew east, one flew west. A third stayed on Earth. When the flights returned, the clocks disagreed. Exactly as Einstein predicted. Decades later, we sent clocks into orbit, and again, they diverged. We now design satellites, spacecraft, and even financial systems with relativity in mind. Our modern world runs on the knowledge that time is not fixed, but fluid. And yet, despite this elasticity, our experience of time remains stubbornly rigid. One moment follows the next. One breath leads to another. We do not feel time slow down, even when it does. This gap between what time is and what it feels like is the growing edge of human understanding. Because as we begin to warp time, to manipulate it with gravity and velocity, we begin to ask deeper questions. Can time be stopped? Can it be reversed? Can it be entered like a room, left like a city? In the next section, we'll peer deeper into the quantum realm, where time may not exist at all, where the illusion of its flow may be something we, ourselves, create. At the heart of time's distortion lies a deeper truth, one that ripples through all of modern physics. The speed of light is not just a speed, it is a boundary. In everyday life, we rarely consider the role of light in shaping our experience. Turn it on, we see by it. We move through it unconsciously. But to the universe, light is the ultimate speed limit. Nothing, not even gravity, can outrun it. And because light defines how information moves, it defines when things happen. Imagine a flash of lightning across a valley. To someone standing nearby, it happens in an instant. But for someone miles away, there's delay, first the light, then the sound. And if you were moving toward the lightning at near light speed, you'd perceive it sooner. Move away and it would seem delayed. The event itself hasn't changed, but your experience of when it happens has. This is not an illusion. It is a feature of spacetime itself. Einstein's insight was simple, yet staggering. If the speed of light is constant for all observers, then time and space must bend to preserve it. Distances contract. Clocks tick differently. Simultaneity, once thought to be absolute, vanishes. What one observer sees as two events happening at the same time, another may see as unfolding in sequence. For someone moving fast enough, your future could already be there present. Your past might still be unfolding for someone else. There is no single now that spans the universe. Each point in space carries its own timeline, its own horizon of reality. This concept, known as the light cone, divides what we can affect and what we can never reach. Imagine a point in space-time, this very moment, here on Earth. From that point, you can draw a cone outward into the future. Everything within that cone is connected to you by light or slower signals. Everything outside is unreachable, unseen, unchanged by anything you do. Look the other way, and you'll see the past light cone everything that could possibly have influenced you by now. These cones define causality, the possible, the real. They are space-time's unbreakable rules. And yet, they also reveal a strange freedom. Beyond your light cone, in regions too far for light to reach you, events may be happening now that you will never observe. Galaxies born, stars dying, civilizations rising or falling. From your point of view, those events haven't happened. From another point of view, they already have. The present, it seems, is not a line but a mosaic. A scattered collection of nows, stitched together by light, always slightly out of sync. So what is time in a world governed by the speed of light? It is not the ticking of a universal metronome. It is the choreography of change constrained by causality. It is the unfolding of interactions, ripples crossing the cosmic sea, limited by light's reach. Light is not just how we see, it is how we know. It is the medium by which the universe becomes aware of itself. And in that knowing, time is born. When we look at a star, we see it not as it is, but as it was. The light from a galaxy 10 billion light-years away is a 10 billion-year-old message. The star might already be gone. The galaxy might no longer exist. And yet, in your light cone, it still burns, still lives. You are seeing not the present, but the past. Ways the past. And so, in a strange way, the universe we observe is a vast time machine. A museum of distant nows, frozen by the speed of light. This gives rise to an eerie possibility. If no two observers agree on simultaneity, is the present just an illusion of the local mind? We like to think of the universe as moving through time, 1 second at a time, from past to future. But perhaps that flow is only visible from within. Perhaps time is not a thing that moves, but something we move through, each on our own line of causality. From a bird's eye view, perhaps all of it already exists. The Big Bang, the present, the last star's final flicker. All part of a vast space-time sculpture. In this sculpture, time is not a river, but a landscape. And we are travelers tracing our own path through it, always confined by the speed of light, always limited by the shape of causality. As we journey through a universe shaped by relativity, one truth becomes clear. Our senses were never designed to grasp time's true nature. We do not feel our own time dilation as we move. We do not sense the bend of space beneath our feet. We live within a thin envelope of perception, tuned for survival, not for cosmic accuracy. To our brains, time is regular, sequential, a steady unfolding. We remember the past, we anticipate the future, but we only live in the present. And yet, even that may be an illusion. Because our sense of now is not immediate. It's stitched together in fragments, signals from the eyes, the ears, the body processed with delay, unified after the fact. You live milliseconds in the past, always. If someone claps their hands across the room, the sound reaches you slower than the light. Your brain reconciles the two, just for the difference, so that you perceive them as simultaneous. But they weren't, not really. You do not live in reality as it is. You live in a model, simulation built by the brain to make sense of the chaos. In that model, time flows forward, smoothly, reliably. But physics says otherwise. So who's right? The equations? Or your experience? Perhaps both. Or perhaps time is not something that flows at all. Perhaps it's something we compose moment by, moment like music. Every culture has tried to define time, to name it, to tame it. The Greeks gave us two faces of time: chronos, the measurable, linear progression, and kairos, the opportune moment, the felt experience of time. Science explains chronos. But we live in kairos. We don't experience nanoseconds or gravitational distortions. We experience longing, urgency, boredom, regret. To the equations, a minute is a minute. To the heart, a minute spent waiting can feel like an hour. A moment of awe can feel like forever. This gap between measured time and lived time is not a flaw. It is where consciousness lives. It's what allows a kiss to linger in memory longer than it lasted. What makes a sunrise unforgettable, though it only glowed for seconds? What lets you revisit childhood in the space between two breaths? Even in a relativistic universe, subjective time is real, and it shapes everything. Consider our modern world. Satellites orbit above us, using clocks synchronized with Earth's surface. Without accounting for relativistic drift times slowing due to gravity and speed, GPS wouldn't work. Planes would go astray, maps would fracture. We would be lost in our own cities. Our machines know the truth, even if our minds resist it. And the more we build space telescopes, deep space probes, quantum computers, the more we must design for a reality where time is elastic, local, and deeply strange. Yet we still organize our lives around shared schedules. We make promises. I'll meet you at noon. We pretend that time is the same for all of us, rigid, fair, measurable. But in truth, no two beings in the cosmos experience the same now. Not a planet, not a photon. Not even to humans walking at different speeds under different skies. Time is no longer a single thread. It is a tapestry, now woven from countless timelines, all overlapping, but never identical. And still, in the face of all this, we yearn for timelessness. We seek moments where time disappears. In music, in love, in meditation, in the stillness between thoughts, in the infinite gaze of a starlit sky. These are not breaks in time, but perhaps glimpses of something deeper, a state beneath change. A substratum, a silence behind the ticking. Perhaps Einstein's equations point us there not just scientifically but spiritually. It's not to dismiss time, but to remind us. It is not what we think. Not solid, not singular. Not a hallway we walk through, but a prism through which we see, and maybe, just maybe, the true nature of time is not something to be measured, but something to be understood, or accepted, or surrendered to. We've followed time as a flowing current, and as a stretching fabric. But now, we step into a realm where neither flow nor fabric seems to apply. A realm of superpositions, entanglements, and uncertainty. The quantum realm. And here, time begins to vanish. To understand how, we must first abandon the familiar. Because in the quantum world, the rules are different, not just strange, but deeply incomplete. At the smallest scales of nature, where electrons orbit nuclei and photons flicker in and out of being, the world is not made of certainty, but of probability. Particles do not travel in clean arcs, exist in clouds of potential described by mathematical waves. A particle is not here or there. It is both or neither, until something forces a decision. This is the infamous collapse of the wave function, the moment when quantum ambiguity becomes classical reality. When something is measured and probabilities harden into facts. But here's the question physicists have struggled with for over a century. When exactly does that collapse occur? And does it happen in time? Or is it what creates time as we know it? In standard quantum mechanics, time appears as an external parameter, a backdrop, stage, like in Newton's day. But unlike other physical quantities like energy or momentum, time is not an operator in quantum theory. We don't measure it the same way. This has led many to a provocative question. If time cannot be observed at the quantum level in the same way as other variables, is it truly fundamental? Several physicists, including Carlo Rovelli, Julian Barber, and others, have argued perhaps time is not a basic ingredient of reality at all. Perhaps it's an emergent phenomenon, something that appears only when we zoom out. When many quantum states blur into a statistical average. In other words, time may not exist for the atom. Time may not tick for the quark. Only we, in our macroscopic world, perceive a sequence of before and after. The universe, at its core, might be timeless. Let's dig deeper. In the 1960s, physicists John Wheeler and Bryce DeWitt attempted to merge quantum mechanics with general relativity. What they created was the Wheeler-DeWitt equation, a mathematical framework for quantum gravity. But this equation has a problem, a strange one. It has no time variable. Describes the universe without referencing time at all. This isn't a glitch, it's a feature. A clue that, at the most fundamental level, the universe doesn't evolve through time. It just is. Like a vast, multidimensional landscape of possible states, none of which are privileged, none of which happen before or after. From this timeless landscape, the illusion of time arises, like heat from molecules or color from light waves, an emergent property, not a core ingredient. This perspective is sometimes called the timeless view of the universe, and it's as radical as it sounds. There is no ticking cosmic clock. There's no master sequence of events. It's only relationship structures, correlations between quantum states. And from those correlations, we somehow derive the story of time. This idea is not simply theoretical. It has consequences. In quantum cosmology, where we try to describe the universe as a whole quantum system, there is no external observer, no one to measure it, no one to collapse its wave function. So what determines its history? Some physicists suggest perhaps observation is relational. Perhaps events only occur relative to other systems, not universally. This is called relational quantum mechanics. In this view, there is no single history of the universe, only partial perspectives, local truths. Reality becomes a web of interactions, not a fixed unfolding in time. And once again, time becomes not a backdrop, but a construct. It's not a path, but a pattern. Not an arrow, but a mosaic of possible conversations between systems, each with their own rhythm. In such a world, cause and effect are not strict rulers of reality, but emergent behaviors from systems that appear to follow time. Let me pause here to ask a deceptively simple question. If nothing changes, does time still exist? In a universe without motion, without any difference from one moment to the next, what would time even mean? This is where quantum theory and thermodynamics touch hands again. Because if time is defined by change, and change is defined by information, then time may be a story told by systems that remember their previous state. Memory becomes key. Information, it turns out, may be the true currency of time. In our everyday world, causality feels sacred. Strike a match and it burns. Touch fire and you recoil. Cause comes before effect, always. But in the quantum world, causality begins to blur. Events no longer fall into neat sequences. In some cases, the universe seems to decide after the fact what has already happened. At the heart of this strangeness is entanglement. Entanglement is the ghostly link between particles twins born together in a quantum womb. It's measure one, and the other responds, no matter the distance. Change one, and the other seems to know, instantly. Einstein called it spooky action at a distance. He doubted it could be real, but today we've tested it. It's verified it. We've entangled photons across kilometers. We've built quantum computers using it. The spookiness is part of reality. But what makes entanglement truly eerie isn't just the connection, it's the timelessness of that connection. In some interpretations, neither particle has a defined state until one is measured. But when that happens, when you force the coin to land heads or tails the other coin, no matter how far away, lands in perfect harmony. There's no signal, no time delay, no cause and effect in the traditional sense, only correlation. A deep, instant knowing. And here's the twist. Sometimes the order in which you measure the particles doesn't seem to matter, or worse, can't be defined at all. Consider the delayed choice quantum eraser, a baffling experiment. A particle is sent through a pair of slits, like in the famous double-slit experiment. It creates an interference pattern, suggesting it behaves like a wave, but if you add a detector to learn which slit it went through, the interference vanishes. The particle behaves like a pointed decision made by being observed. Now, add a twist. Delay the measurement of which path information until after the particle hits the screen. Logic tells us the pattern should be fixed already. But somehow, the future measurement seems to reach back in time and change the past behavior of the particle. It's not that information is traveling backward. It's that in the quantum realm, the past is not set until it is observed, until it becomes part of a record. This is not time travel. This is something stranger. This is the erasure of time's order altogether. And so we arrive at a radical idea now emerging in quantum research. In some systems, the sequence of events might not just be uncertain, it might not exist. Physicists are now exploring frameworks where event A causes B, B causes A, or neither causes the other. In these situations, the events are in a superposition of orders both before and after each other at once. Think of a quantum switch, a system where operations can be applied in multiple sequences simultaneously. This isn't theoretical. It's been built in labs. And it suggests that even time's flow, its order, is a quantum variable, where there is no fixed past, no assured sequence. Only a web of possibilities, flickering until something, a measurement, a memory, locks it in place. This shatters the arrow of time, not just bending it, but unweaving it. We're now standing at the edge of what science can presently test, and peering into the philosophical. If order is relative, if events have no fixed position in time until observed, then what does it mean to experience time? Is our perception of sequence merely a way to make sense of chaos? A narrative stitched together after the fact? Do we, as observers, create time by observing it? Or do we simply surf the surface of a deeper quantum ocean, where time is not a line but a shimmering interference pattern? In the quantum world, we find no ticking clocks, no pasts, no futures, only relations, probabilities, measurements. And memory, perhaps the only thread that gives us a sense of before. This brings us to one final whisper from the quantum abyss. Perhaps time as we know it emerges not from particles, from entanglement itself. In 2013, physicist Mark van Ramsdonk proposed that spacetime may emerge from quantum entanglement, the geometry of the universe. And even time's fabric is a product of how information is shared between particles. In this picture, spacetime is not the backdrop but the result. The surface tension of an ocean we cannot see, and time is just the ripple on that surface. If true, then the deep structure of the universe is not made of time and space at all, but of information. A cosmos not composed of things in motion, but of relationships in flux. Quantum conversation echoing across a timeless void. If time, at its core, does not exist, then what does that say about us? We are creatures of memory, of anticipation, of rhythm. We wake to morning light. We age. We grieve. We celebrate anniversaries. We carry the past in our bones and dream forward into futures that may never come. Everything about our identity is wrapped in time. But if quantum physics is whispering the truth, if time is not fundamental, if it is not real in the way we believe, then all of those things we call our story may not be a sequence at all. They may be a cloud, a collage. Moments scattered across a timeless canvas, stitched together by consciousness, not chronology. In such a universe, you are not a traveler moving through time. You're a pattern emerging from correlations. A harmony and a quantum symphony heard locally, known temporarily, but not necessarily bound to a before and after. This idea is not without precedent. In some interpretations of quantum mechanics, the observer is not outside the system. They're part of it, entangled with it. The act of observation isn't about watching something unfold. It's about participating in what becomes real. Your awareness doesn't just notice time. It may be part of what generates it. And that awareness, that string of moments you call life, it may not be a line. It may be a loop, or a field, or something for which we have no language yet. You are not a point moving forward. You are a constellation of experiences coexisting. It's timeless, from the right perspective. This brings us to perhaps the most poetic and most challenging implication of a timeless quantum world: death. If time is not fundamental, if the past still exists, then perhaps nothing is ever truly lost. Perhaps the child you once were still lives, frozen like starlight on a frame of the universe's fabric. Perhaps those you've loved and lost still are, not in memory, but in some quiet corner of the wave function, still entangled with you, still echoing. From within time we grieve, but from beyond it, perhaps there is no need, only presence, only pattern, only now. This is not science fiction. It is a frontier of science, blurred with philosophy, resonant with spiritual depth. It does not mean we will live forever, or that we can reach into the past. But it does suggest that the universe is far more than a machine winding down. It is something alive with possibility. It's not linear, not fixed, not even unfolding, but being. And we brief luminous phenomena are not separate from this strange eternal structure. We are part of it. So what then is a moment? If the universe is timeless, why do we feel time at all? Perhaps it is not time we feel, but change. And not change in matter, but change in information. Each moment, your brain updates its model. Each breath, you shift from one entangled configuration to another. Each heartbeat, a new pattern of correlations crystallizes, then dissolves. Time may be nothing more than the experience of these transitions, a sense of movement through a field of timelessness, a rhythm created by attention, by memory, by choice. And this, perhaps, is where science hands the baton to consciousness. Because in a universe without clocks, you are the metronome. In this part, we explored time from the quantum view. Time may not exist at the smallest scales. Measurement creates what we call sequence. Entanglement may precede and define spacetime. We, as observers, help shape what becomes real. Memory and information, not time, may be the true drivers of experience. And so, what we call a life may be a wave, not a line, a pattern, not a passage. It's a song, not a schedule. What if this very moment, right now, as you hear these words, is not fleeting? What if it's not passing through you, or you through it? What if this moment always was, always is? This is the vision offered by a concept called eternalism, often referred to in physics as the block universe. It is not speculation. It is a direct consequence of Einstein's theory of relativity. When Einstein showed us that time and space are woven together into a single fabric, space-time, he also removed any universal now. What is present for one observer may be future for another. The sequencing of events becomes relative observer-dependent, and if no moment holds primacy over another, then all moments must be equally real. Just as every point in space exists, even if you're not standing there. As every point in time exists, even if you're not living there. Past, present, future, all locked into the structure of space-time. Like the pages of a book you haven't yet turned, but which are already printed. You are not riding the wave of time. You are embedded in a block of four-dimensional entity where time is simply another direction. To visualize it, imagine your life as a film strip. Each frame is a moment. From your first cry to your last breath, each scene is there fixed, immutable. You are watching the film frame by frame, unfolding second by second. But the real already contains the whole thing. This is the block universe. The future is not something that becomes, it already is, just unseen from your current perspective. Einstein himself was deeply moved by this idea. In a letter to a friend's widow, he wrote, "People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion, not a poetic metaphor, a physical truth. Time does not flow. It simply is. But how can this be? How can the future already exist if we haven't seen it? How can the past still be there if it's gone?" The confusion lies not in time, but in consciousness. We experience time sequentially, moment to moment, memory to anticipation. But the brain, the body, the self, they are mechanisms within the block. Like a camera panning across a mural, they give us the illusion of motion, of unfolding. The mural doesn't move. It's already there. In the block universe, change is not fundamental. What we call change is the variation across slices of space-time. Each slice, each moment, is complete unto itself. It contains you, as you were, as you are, as you will be. And from the right vantage point, the whole sculpture is visible, still, complete, eternal. This vision of time is unsettling, yet strangely beautiful, because it suggests that no moment is ever truly lost. Your childhood is not gone, it is simply elsewhere in the block. Your last embrace with a loved one still exists. your finest hour, your deepest sorrow. All of it, forever etched into the structure of the universe. You may not have access to them, but they are not erased. They are simply fixed. We live, we love, we part. But in the block, nothing ever leaves. It is all held, crystallized in the amber of spacetime. This view also reshapes our understanding of cause and effect. If the future already exists, does that mean everything is predetermined? Not necessarily. From within the block, you experience choice, you deliberate, you change your mind. Your brain follows pathways shaped by chemistry, context, and memory. To you, it feels like freedom, and it is, from your frame. But from outside the block, if such a perspective could exist, your entire path is already there. Every fork taken, every word spoken, every silence chosen. Free will then becomes a matter of perspective. You are choosing within your frame. But that choice, like everything else, is part of the sculpture. From the outside, the choice was always going to happen. From the inside, it was never known. We'll pause here in this section, having introduced the foundations of the block universe and its emotional implications. In the next section, we'll explore how eternalism challenges our notions of beginnings and endings. The difference between being alive in time and being alive in eternity. Why the arrow of time still matters to us, even inside the block. If the block universe is real, if all moments exist simultaneously, fixed and immutable, then what becomes of our notions of beginning and end? We are creatures drawn to stories. We like clear origins, climaxes, conclusions. A hero is born, a journey begins. A final breath closes the chapter. But in eternalism, nothing truly begins, and nothing truly ends. It simply is. Always. The Big Bang. Not a spark from nowhere, but a fixed coordinate in space-time. Forever at the start, but not before anything, because in a block, there is no before, only elsewhere. Your death. Not an erasure, but a location, another point in the mural. Still part of the painting, still part of the you that spans across the sculpture, in your birth. Not the start of you, but one region of a continuum, one section, in which the pattern of you is dense with potential. Nothing comes into being. Nothing disappears. Everything simply exists in its own place on the map. It is not a comforting idea. It denies motion. It denies change. Even denies the drama of becoming. But it preserves something else, something haunting and strangely sacred. Permanence. In a flowing universe, the past is gone. The future is unreachable. But in the block universe, every tear, every kiss, every heartbeat remains. Not as memory, not as echo, but as structure. This view forces us to reconsider the very meaning of presence. What does it mean to be? Are you only alive in the slice you call now? Or are you, in some deeper sense, everywhere your existence spans? From the child who scraped a knee, to the teen who wondered about the stars, to the elder watching twilight fall? All of them exist. Not as ghosts, not as shadows, but as fixed living parts of the block hall, equally real, or not a traveler moving from one self to another. You are all of them simultaneously seen from different angles. This is the eternal you, not born, not dying, just being in all directions. It is humbling, it is terrifying, and yet somehow deeply grounding, because it means that even the version of you that suffers, the one who endures the hardest hour, is held permanently in the tapestry of the real. You do not vanish, you are preserved. Still, one might ask, why do we feel time's passage? Why do we experience now as moving if the block is still? The answer lies in something we've touched before, the arrow of time. Even in a frozen block, not all moments feel the same. Entropy increases in one direction. Memory exists only backward. You remember yesterday? You cannot remember tomorrow. This gives rise to subjective flow. To you, time moves forward because your mind is built to perceive increasing entropy. Your brain is a thermodynamic system, encoding, storing, forgetting. From inside, it feels like progress, like motion, but it's not that time flows. It's that your experience moves along a path with memory behind and uncertainty ahead, a trail through the block. So even if the universe is still, you are not. Because you are not the block, You are in motion through it. And in that motion, the illusion becomes reality, not because it's false, but because it's felt. But what about choice? What about the future? If the future already exists, do our actions still matter? More than ever. Because your path through the block is not passive, it is shaped by your mind, your will, your values. From your perspective, each decision is real, uncertain, alive. You stand at a branching point, not because the tree is still growing, but because you have not yet seen its shape. You may not be writing the story, but you are reading it for the first time. And in that reading, it matters deeply how you interpret it, how you respond, how you choose to live each moment that, in some other frame, already is. There is a dignity in that, not because you control the block, it's because you bring it meaning. In the traditional story of time, everything fades. The past slips away, the future waits in shadow. The present is all we're given, and it's already leaving. But in the block universe, nothing fades. Nothing leaves. Nothing is left behind. What we lose, we still contain. The father whose voice no longer echoes across the dinner table. The friend whose last message lives only in a saved file. The childhood home that now stands empty. They are not gone. They are simply elsewhere in the sculpture. And though we cannot return, though our thread moves forward, those coordinates remain, fixed, held, crystallized forever in the geometry of space-time. Grief, in this view, becomes not the ache of loss, but the recognition of distance, longing for a point in the structure you can no longer reach, but which nonetheless exists. This does not erase the pain, but it reshapes it. It tells us you have not lost them. You have simply moved beyond their frame. They are still there like stars beyond the visible horizon. We often speak of legacy as something we leave behind, a trace in the world, a name remembered, ripple in the pond. But if all moments exist, if the block is real, then you do not leave legacy. You are legacy. Your life is already woven into the fabric. Every smile you gave, every hand you held, every quiet act of courage, they do not echo. They are etched. Forever present, forever real. You need not be remembered to remain. You need not endure in others to exist. You already do. Not just in memory, in structure. This changes the very question we ask when we wonder about life's meaning. If we are not passing through time, if we are instead stretched across it, then meaning is not something we build through motion or time's passage. Meaning is relational. It lives in the shape of your existence across the block. How you lived, where you touched others, what pattern you left behind in the constellation of your life. It is not what you become. It is what you are in the geometry of everything. And what of presence? What does it mean to be here if all here's are fixed? It means that presence is not location, it is attention. You are always somewhere in the block. But where you direct your awareness, that is your moment. That is your truth. You are not just the events of your life. You are the awareness that travels through them, like a light scanning the facets of a diamond. You animate the sculpture. You breathe life into what is otherwise frozen. Without consciousness, the block is silent, but with it, it becomes a story. And you, brief, luminous flame, are its narrator. In this part, we explored the profound implications of the block universe. All moments are equally real. Past, present, future. Nothing vanishes. Everything is preserved in space-time's geometry. Presence is attention, not position. Meaning is pattern, not passage. And grief becomes a kind of distance, not destruction. You are not a fleeting flame burning through time. You are a structure, luminous and enduring, a part of the cosmic architecture that holds everything forever. There is a paradox at the center of our experience. We live in a universe that may be timeless. Physics tells us past and future are equally real. Quantum theory suggests that time may not even exist. Space-time, at its deepest level, may be a static tapestry, and yet we feel it. We feel time as surely as we feel breath, a rhythm beneath every thought, a current that carries us from birth to death. We call it the present. But even that word betrays us, because by the time you notice this moment, it's already gone. The mind does not experience time as it is. It constructs it. In fact, neuroscientists have found that your brain operates with delay. Each sensory signal, light, sound, touch, takes time to process. Milliseconds pass between reality and awareness. And yet we do not live in lag. Our brains do something extraordinary. They synchronize, compensate. They align the scattered inputs into a coherent now. But this now is not a moment. It's a window. Roughly 2 to 3 seconds long, a moving spotlight that frames your conscious awareness. Within that window, your mind stitches together what just happened with what's happening now. It's not a photograph, it's a film. Smooth, sequential, crafted moment by moment from fragments. This is the illusion of flow. And yet, it's more than an illusion, because in this stitched narrative you find identity. You remember what just occurred, you anticipate what might come. And in that tiny difference between what has happened and what could, you find yourself. Without memory, there is no self. Without anticipation, no direction. Without both, no time. You do not merely perceive time, you generate it. And that generation is deeply tied to consciousness. Consider a simple observation. A bird in flight. To your eyes, it moves smoothly from branch to branch. But in truth, your brain sees it in frames. Each glance, each flicker of motion, is captured and updated dozens of times per second. And yet your perception smooths it into a single elegant arc. You don't notice the stutter. You see the story. This ability, this smoothing of chaos into coherence, is the essence of time as we know it, when it reveals something quietly profound. Time is not just what happens, it's what the mind allows to make sense. Why do we remember the past, but not the future? Physics offers no strict reason why time should flow one way. The laws, Newtonian, quantum, relativistic, are symmetric. They run the equations forward or backward, and the math still holds. But our minds are not symmetric. Your memories point in one direction, always behind. No one wakes with full recall of tomorrow. No one forgets the pain of yesterday before it happens. We are not time machines. We are filters. Or perhaps, recorders. And the key lies in a single word: entropy. Entropy, the measure of disorder, increases in one direction. The tea cools, the glass shatters, the echo fades. And with each increase in entropy, information is lost. When we burn a letter, we do not just lose int, we lose meaning. When a moment passes, we cannot reassemble its atoms into precisely what was. The universe forgets, but your mind does not. It fights the current. Your brain is a fortress against entropy. It encodes, it stores, it recalls. And yet it too is subject to decay. Memories fade, details erode, faces blur. So while entropy governs the physical world, it also shapes the biological one. You remember the past not because it is special, but because you recorded it. You laid down the neural trace, the chemical map, the echo. You cannot do the same for the future, because it hasn't passed through you yet. You haven't touched it. And so your perception of time is not built on clocks, but on asymmetrical access to information. What is past is data, what is future is speculation. This is why time feels real, because the mind gives it a gradient. You stand at a place where information is rich behind you, and absent ahead. Like a candle lighting a dark hallway, you illuminate what's been, but not what's coming. That's not a failing. That's how presence is formed. Without forgetfulness, the moment would not stand out. Without limitation, there would be no now. Just an infinite panorama of being. But the mind needs focus. It needs loss. It needs direction. In other words, to feel time, you must not see all of it. Even the structure of memory reveals this. Short-term memory operates like a buffer, temporary, shifting. Long-term memory must be encoded through emotion, repetition, or novelty. And retrieval, that's never perfect. It's an act of recreation. You don't access memories, you rebuild them, each time, with noise, with bias, with distortion. So even our picture of the past is not stable. It is narrative. It is reconstructed time. Your life, as you recall it, is a tapestry woven from impressions, not recordings. And perhaps that's the point. You do not live in reality as it was. You live in meaning, in association, in story, in story. Requires direction. What then is time? A dimension, an arrow, a field, or is it a function of consciousness? We've seen how physics challenges time's reality, how quantum mechanics dissolves sequence, how space-time freezes the past and future into one. But for all this, one truth remains. You feel it. You feel it when a loved one leaves, when a child outgrows a toy, when music swells, holds, and fades. You don't measure time with clocks. You measure it with change, with memory, with emotion, and if those experiences are real, then so is the time that holds them. Because an illusion is not a lie. It's a frame, a way of seeing. A rainbow is not an object. It's a phenomenon of light and angle. A horizon is not a place. It's a consequence of your vantage point. So too with time. It may not be a thing the universe contains. It may be something we generate the way color emerges from wavelength or warmth from molecules. We are not inside time. Time is inside us. It is how we arrange the world, how we move through uncertainty, how we become. This does not diminish time's importance. It elevates it. Because even if the universe is timeless, you are not. You are a pattern that perceives change, system that compares before and after, a creature who remembers. And in that remembering, time is made. The ticking clock is a tool, but the heartbeat is a truth. You do not need the cosmos to confirm the flow of time. Your breath does it for you. So what does it mean to live in a world where time is constructed? It means you are the artist, and the brush is attention, canvas, perception, the pigment, memory. You create continuity not by marking days, but by choosing what to carry forward, what to hold, what to let go. And in that curation, life becomes story, a non-linear, flickering, imperfect story, but a story nonetheless. And like all stories, it is not diminished by being made. It is made sacred by being felt. This is the paradox of time. It may not be fundamental, yet it is foundational to thought, to identity, to love. Time is the price of meaning, and the medium of meaning itself. It is illusion. But it is the most human illusion we have. And perhaps that makes it real enough. What if the end is not the end? What if time, like space, curves back upon itself? Not in the mind, not in memory, but in reality. This is not fantasy. It is a mathematical possibility, born not in myth, but in the equations of general relativity. They are called closed time-like curves, and they are solutions, valid ones, to Einstein's field equations. A closed time-like curve, or CTC, is a path through space-time that loops back to its starting point in both space and time. Imagine taking a long walk and ending up not just where you began, but when you began. A perfect circle, not around the sun, but around a moment. These aren't mere thought experiments. In 1949, Kurt Gödel, the same Gödel who shattered logic with his incompleteness theorem, discovered a model of the universe in which CTCs naturally occur. His rotating universe didn't just twist space, it twisted time. In Gödel's cosmos, you could, in theory, fly your spaceship in just the right curve, arrive at your own past. This result wasn't fantasy. It followed directly from Einstein's equations, and it left the physics community uneasy, because if you can return to the past, what's to stop you from changing it? The idea of a time loop brings with it more than wonder. It brings paradox. The most famous is the grandfather paradox. Travel back in time. Prevent your grandfather from meeting your grandmother. What happens to you? If you were never born, how did you go back? It's a loop that eats itself. A snake devouring its own origin. And yet some physicists believe these loops don't collapse logic. They simply force it to comply. In the 1990s, physicist David Deutsch proposed that in a quantum universe, time loops might still allow consistency. Events in the loop cannot contradict each other. Try to stop your grandfather. Something will always intervene. You'll fail no matter how hard you try. This is the Nevikov self-consistency principle. You can travel back in time, but you can't change it in a way that undoes your own existence. The universe, it seems, protects causality, even in a circle. But this raises a deeper question. If loops exist, are we already inside one? Not as individuals, but as a cosmos, Some cosmological theories suggest the universe may not be a one-time burst, but a series of repeating cycles: expansion, contraction, rebound. This is the cyclic model. Unlike the block universe, which preserves all moments at once, the cyclic model envisions repetition, not just memory, not just preservation, but return. What you call now may one day recur, not in your mind, but in cosmic reality. Perhaps this is not your first time hearing these words. Perhaps this moment has unfolded before, and will again. Not metaphorically, mathematically. The universe allows strange possibilities, wormholes, singularities, multiverses, but perhaps none are stranger or more unsettling than a door to the past. In theory, time travel doesn't violate the laws of physics. Under general relativity, spacetime can bend, stretch, even twist upon itself. And in those rare configurations, it might fold. This is the domain of wormholes. A wormhole is a shortcut through spacetime to distant regions connected by a tunnel. If one mouth of the wormhole experiences time differently than the other, say by being moved near a black hole or accelerated close to light speed, then time between them becomes misaligned. Step through one side. You emerge not just elsewhere but elsewhen, the equations say. It's possible. But reality may say otherwise. Physicist Kip Thorne, who helped design the science behind Interstellar, explored this idea in the 1980s. Could wormholes become time machines? Yes, he concluded. But only if exotic matter existed, something with negative energy density to keep the wormhole open. And that if is no small thing, because every known form of matter collapses under gravity. Wormholes left unchecked snap shut. Time loops vanish before they can form. It's as if the universe says, "This way lies paradox. Best to close the door." Enter Stephen Hawking. He proposed what he called the chronology protection conjecture, safeguard woven into the fabric of physics. The idea is simple. If time loops threaten to emerge, the universe destabilizes them. Quantum fluctuations surge. Energy spikes. The structure collapses under its own weight. In essence, reality fights back. The conjecture isn't a law, but it expresses a principle that seems to hold true. Nature abhors a paradox, and perhaps that's not just convenience. Perhaps it's self-preservation. But even if time loops can't be engineered, they may still exist in the equations. Physicists explore solutions where causal loops appear, events where the effect precedes the cause. A researcher receives blueprints for a machine from the future. They build it. The machine works and sends those same blueprints back. Where did the design come from? Nowhere or everywhere. It is self-originating. A loop of cause and effect that closes upon itself. Such loops don't violate logic as long as they're consistent. They disturb our sense of origin. They deny the need for a beginning. They allow information to appear from nothing, and yet not from nothing. In quantum terms, such loops might arise in post-selected systems where outcomes are constrained to match future measurements. You measure a particle's state, but somehow seem to have known that measurement all along. A loop not in space, but in possibility. So if the universe allows such loops, why don't we see them? Why do we live in an orderly world where events follow one another cleanly? There are several possibilities. One is practical. The energy required to sustain time loops is beyond reach. Another is structural. Time loops may exist only at microscopic scales, hidden in the foam of quantum space-time. A third is anthropic. In timelines where paradoxes reign, observers cannot exist. They collapse before minds like ours can emerge. In all cases, the message seems clear. Time loops may be possible, but they are not permitted to unravel meaning. The universe may tolerate the loop, but not the breakdown of truth. Not that is what keeps the arrow alive. Long before the language of relativity and wormholes, ancient civilizations gazed at the stars and saw loops. The heavens turned in circles. The moon waxed and waned. Seasons died and were born again. Rivers flowed, evaporated, returned as rain. To them, time was not a line, it was a wheel. The Hindus spoke of kalpas, vast cosmic ages repeating in rhythm. The Stoics believed in ekpyrosis, the universe born in fire, destroyed in flame, then reborn. The Maya encoded recurrence into their calendars. The Norse spoke of Ragnarok, not as an ending, but as the seed of a new beginning. To live was not to travel forward. It was to cycle, and perhaps they were onto something. Today, some cosmologists entertain a similar thought. What if the universe does not end but resets? In this view, the cosmos expands, cools, and then collapses, only to begin again. A grand rebound, a big bounce. This is not poetic fancy. It is a proposed answer to the deepest question in cosmology. What came before the Big Bang? If space and time are not infinitely stretching but oscillating, then what we call the beginning is simply the midpoint of a grander curve. You are not at the start of the story. You are inside a recurring stanza. This is more than metaphor. In conformal, cyclic cosmology, developed by Sir Roger Penrose, the idea is radical. The end of one universe, the heat death, when all is cold and structureless, may look from a certain point of view, just like the birth of a new one. When temperature and distinction vanish, scale becomes meaningless, and when scale dies, so does time. A featureless future becomes indistinguishable from a primordial past. One eon gives rise to another, eternally, like breaths, like tides, like heartbeats on a cosmic scale. But if the universe repeats, what does that mean for you? Do you return? Do the same stars burn again? Do the same choices play out exactly, inexorably? This is the haunting proposition of cosmic recurrence. If the universe is finite, but eternal, if the number of configurations is vast, but not infinite, then eventually they must repeat. It's not just similar worlds, but identical ones. One day, another you may sit where you are, listening to these same words, under the same sky. Not because fate demands it, but because mathematics permits it. In an eternal system, everything that can happen must again and again. Friedrich Nietzsche called this eternal return. He didn't mean it as science, he meant it as test. If you had to live your life exactly as it is, forever, would you still choose it? It's a question that doesn't need truth to be powerful. It only needs your attention. Because whether or not the universe loops, whether or not recurrence is real, you live this moment only once. And the loop that matters most is not cosmic. It is within. It is the way you return to a memory. The way love resurfaces, the way a single decision echoes forward through the shape of your life. The loops of time may be beyond reach, but the loops of meaning are always near. In this part, we explored the possibility that time may not only be experienced in loops, but structured as such, closed time-like curves, which may exist in general relativity. Time travel may be possible, but paradoxes are constrained by consistency. Wormholes and causal loops challenge the origin of information. The universe itself may be cyclic, expanding, collapsing, and rebirthing forever. An eternal recurrence, whether scientific or philosophical, urges us to reflect on how we live now. Time may not just move forward, it may return, and in that return lies a strange kind of forever. Time may be an illusion, but it is the illusion we live within. It governs our stories, it shapes our love, gives meaning to every beginning and every end. So even if physics whispers that time is not fundamental, even if the cosmos contains no clocks, we still must ask, why do we care so much? Because if time is not real, then why does its passage make us weep? Perhaps the answer begins with urgency. We care about time not because we understand it, but because we feel its cost. Every moment we love, every chance we miss, every person we lose, is framed by time's departure. The illusion of time doesn't hurt us because it's false. It hurts because we are bound to it emotionally. If that illusion disappeared, if you could live in an eternal now, untouched by change, would love still matter? Would memory? Would meaning? Time matters because it limits. And in that limit, we discover what we value. Even in a block universe where all moments exist, even in a timeless quantum field where nothing truly happens, you still experience time. You age. You reflect. You regret. You hope. Those experiences are not invalidated by physics. They are contextualized by it. Because time's unreality does not strip it of meaning. It reveals meaning as a property of perception, not particles, like color, like beauty, like joy. They don't exist outside of us, but they exist in us, utterly, vividly, undeniably. And so it is with time. Let's pause here in this section. In the next, we'll explore how spiritual traditions have dealt with time's dual nature, why timelessness is both a scientific idea and a mystical state, and how presence might be the only real form of time we ever touch. Long before relativity, before clocks, before equations bent spacetime, there were those who sensed that time was not what it seemed. The mystic sits in meditation, and hours vanish like breath. The monk chants and enters the eternal. The shaman journeys beyond time, into the dream that holds all dreams. Across cultures, time is not always a line, but a veil, a surface, trance. And to awaken from it is to glimpse the real. In Hindu philosophy, time is Maya, an illusion. What's real is the Brahman, the eternal, unchanging, all-pervading presence. In Buddhism, the self and, by extension, time's a mental construction. Enlightenment is not found in some future event. It is discovered in presence, the still point behind all becoming. In Christian mysticism, the kingdom of God is not a future realm, but a state of being outside time, a place where God is not tomorrow or yesterday, but always now. And in Sufi poetry, time is called a trap, a river that must be crossed to reach the ocean of timeless love. These are not poetic metaphors. They are direct encounters with altered states of time, moments where the clock ceases, and consciousness expands. Modern neuroscience offers glimpses of the same mystery. In states of deep meditation, the default mode network, the brain's time-tracking center, goes quiet. Time doesn't stretch or shrink. It vanishes. People report a sense of stillness, being everywhere and nowhere, of now expanding into forever. These aren't delusions. They are neurological shifts, states measurable on EEGs and fMRI machines. In flow states, athletes, musicians, and artists speak of losing time, of becoming one with action, of being neither before nor after, but inside. This is timelessness as experience, not theory, not belief. And perhaps this is the paradox. We are creatures of time, yet our deepest peace arises when we forget it. We do not need to abolish time to escape its grip. We need only return to the now, the moment before it is divided. It is in presence that suffering eases, that fear fades, that joy deepens. The eternal is not beyond time, it is beneath it, always here, waiting, unchanged. If time is illusion, then so is urgency, so is progress, so is loss. And yet those illusions shape our lives more than any fact. We build cathedrals for the future. We grieve what's gone. We fight for change. We whisper, "I love you" at the edge of time. If time isn't real, then meaning must live within the illusion. And maybe that's the most human thing of all, to live as if this moment matters, even if all moments are already etched in eternity. We are story-driven creatures. Our minds do not function in snapshots. They build arcs, beginnings, middles, ends. And what is a story? But a journey through time? Even if time is a fiction, it is one we require, because without it, there is no becoming, no learning, no redemption, no love that grows with years, healing that unfolds in seasons. Without time, everything just is. But with time, everything can change. And in that change, we find hope. So what does it mean to live meaningfully in a timeless world? It means this: you do not need time to be real for your kindness to matter. You do not need an objective flow for your choices to ripple outward. You do not need a future to arrive for your love to last. Meaning is not granted by the cosmos. It is created by you and the way you show up for the moment, the way you inhabit the illusion, fully, freely, with reverence. Time, like music, is made of intervals, of pauses, of returns. And even if it's not a force, even if it's not a dimension, it is still the rhythm of our becoming. We move, we reflect, we fall, we rise. And in doing so, we write lives worth remembering, not because time exists, but because we do. In this part, we explored the emotional and existential resonance of time, even if it is not fundamental. We care about time because we care about change. Time may be illusion, but meaning arises within it. Mystical traditions have long treated timelessness as a path to awakening. The present moment is where eternity and experience meet. Living with presence is not a denial of time, but a mastery of it. So even if the physicists are right, even if time does not flow, even if past and future are illusions stitched by the mind, still you are here. And here is enough. Perhaps time is not real. Perhaps the past is still here. Perhaps the future has already happened. Perhaps now is only a trick of light reflected in memory, filtered through perception. And yet we live, we love, we mourn, we begin again, we chase seconds, we fear their loss, we celebrate their passage. We mark them not because they are solid, but because they are fleeting. We dance through illusion, and in doing so, make it real. Science tells us time may be an emergent property, a construct of entropy, consciousness, or cosmic coincidence. But meaning does not wait for confirmation. Meaning is how we move through the world, even when the floor beneath us may not be real. So whether the arrow flies, loops, or never was, live with presence. Speak with depth. Love as if time matters. Because for you, it does. And perhaps that is enough. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Till next time, keep asking, keep looking up, and never stop wondering.